Hey guys, welcome back to my channel. Today we're going to be doing geometry and we're going to focus on triangles for today. If you want, you can purchase my triangles pack. It's a full 6-page pack on triangles, all the different types of triangles and how to do any working out regarding triangles. You can get it on my website www.mrsdupre.co.za. Okay, going straight into it. First of all, we're going to do types of triangles. Before we start on the types of triangles, we need to know a few facts about triangles. First of all, we know that a triangle has 3 sides. We also know that a triangle has 3 angles as well on the inside. So we're just going to call them 1, 2, and 3. Now, did you know that, I'm just going to take this away. Did you know that the sum of the angles on the inside of a triangle all add up to 180 degrees? Now, a lot of people just agree with it and they say, yes, that's right. But have you ever tried to actually do it yourself to see, is this actually true? So there is a way, and what you do is you actually cut out a triangle and you label it 1, 2, and 3 on the inside. And what you can do is you tear each angle out. Okay, so there's angle number 1, there's angle number 2, and we've got angle number 3. Now, you must agree that I've just taken, all I've done with the triangle is I've just taken its corners off. So technically, it should all still work out perfectly if you see that. So there's my triangle still. All I did was I tore the angles off. What I'm going to do now is I'm actually going to take the angles and I'm going to just position them on this line. You'll notice I'm putting the straight line at the bottom and the other straight side on that side, and then the torn pieces on the outside. We're going to do that with all 3 of them. You've got 1, and you've got 2, and you've got 3. Can you notice that they fit perfectly on this line to make it a perfect 180 degree angle? Now, it doesn't matter what size your triangle is. You can have a nice big one, which I'm sure you can see is bigger than the last one. And I can do exactly the same thing. And I just want to prove to you that this does actually work, no matter what triangle you use. So we're going to tear them out again. And then we're going to position them onto the line. So I've got a few extra lines down below. And we're just going to position them again. It doesn't actually matter which way you put them. They don't have to necessarily be in order. But just to give you an idea, that even if I do jumble them around, obviously you'd stick them down with glue, makes it a little bit easier, but you'll notice that still it adds up to 180. Now here's a smaller triangle that we've got, okay, and again, just quickly, we're going to do it again, last time, just to make sure that you are 100% convinced that it is 180 degrees for all 3 angles. And this doesn't matter what triangle you have. You can have an obtuse angle triangle, you can have a right angle triangle, you can have a scalene triangle, and it doesn't matter. Whatever the 3 angles are of your triangle, they will always add up to 180 degrees. Okay, what I've got on this pack, that if you do purchase it, you'll see that I've actually given you 3 triangles to cut out yourself. So I've given it to you with dotted lines, so you would cut it out, you'd tear it across where your dotted lines are over here, and then you would stick it back onto your page to see your 180 degrees. Okay, that's just for extra, just to make sure that I'm not cheating you guys at all this, so you can see for yourself. Okay, now when it comes to knowing that, now we know that 3 angles on the inside of a triangle add up to 180. That means we can really work out what's happening in a triangle. So if you are given 2 angles inside a triangle, it is very easy for you to work out what's happening on that last angle that you don't know. Okay, let's start with the first example. Here we have a right angle triangle. We know it's a right angle triangle because it has a right angle. And we know that a right angle is 90 degrees. We've been given 52 degrees and we've got a missing angle. I've named the missing angle X. Okay, just to make it easier, easier to write out, and easier just to show your working, I suppose, in the end. Okay, so we're going to write it all out. We know that those three angles together will add up to 180 degrees. Okay, so we just write it out. 90 degrees plus 52 degrees plus x equals 180 degrees. Now let's just work out what 90 plus 52 degrees is. We know that that is 142 degrees plus x equals 180. Now you're probably wondering, how do I get the x? Well, we know that if I take 142 away from the 180, I should get my answer. So x equals, we're going to take 180 degrees, we're going to minus 142 degrees from it, and we're going to end up with a 38 degree angle. And that is your answer for that one over there. Okay, nice and easy. Now, just a little hint. If you can't do 90 and 52 in your head, no one is stopping you from taking a pencil, just grab a pencil quickly, and doing a quick little sum on the side of your page and quickly doing it. Okay, no one is stopping you. All you have to do is erase it afterwards, or even just leave it. Just depends on your teacher. Some teachers like the working out on the side, some don't. So obviously just play around with that. But if you cannot do the adding and you can't do the subtracting in your head, then please show working out. Just do the working out just so you get the correct answer. Okay, there's no point in trying to, work it out in your head when you actually don't know what you're doing. Rather just know that you can do this on the side, and then you know you'll get a correct answer. Okay, let's move to the next one. Okay, we've got a very similar kind of question. Here we've got a triangle again. This time it's a 90 degree angle. I'm just going to put in a 90 there. I've got a 30 degree angle, and I've got a missing angle. We'll call it x again. You could call it y, a, b, whatever you want. Okay, it doesn't matter. All means the same thing at the end of the day. And we're going to do exactly the same. So we know we're going to add the three angles together. Plus x equals 180 degrees. And we're going to know that 90 and 30 adds up to 120. We still have our x, and we know it still adds up to 180. And then in order to get the x on its own, we're going to take the 120 and take it to the other side, make it a minus, and we get 60 degrees. Okay, let's go to number 3. Okay, so this triangle is a little bit different to the other ones. You'll see it's got two 40-degree angles and then a missing angle. So what we're going to do is we're going to do exactly what we did in the other ones and add them together. We're going to call this one x as well, and we're going to add them all together, and we're going to make them all equal to 180. So we know that the inside angles of a triangle now add up to 180. So we know this is 80 degrees because 40 and 40 is 80. We still have our plus x, and that's 180. And I'm sure you can figure it out that x equals 180 degrees minus 80 degrees, and you probably knew this already, but it's eventually equal to 100 degrees, which makes sense because if you look carefully, can you see that this is an obtuse angle? And we know that an obtuse angle is anything bigger than 90 degrees. So it makes sense that it's 100 degrees. And then our very last one, which is pretty much the same as what we've been doing with the other ones, is we've got a 50-degree angle, a 90, and a missing angle, and we're going to do the same thing again, very last time, so I'm just going to fix that. We've got 90 degrees plus 50 degrees plus x equals 180 degrees. We've got 90 plus 50 equals 140. We still have our x. We've got that. We've got x equals 180 minus 140 equals 40 degrees. And we are done with those questions. Okay, so now let's look at how the angles can help us to identify or classify a triangle. So what we've got here is we need to start working out what kind of triangle are we dealing with. And the way we do that is by looking at either the size of the angle or by looking at the length of the sides. But we're going to focus on the size of the angle first. So let's go with this first. So there are three types of angles, or sorry, three types of triangles that you get that we use the size of the angle. Now, the first one is an acute angle triangle. Okay, so this is what an acute angle triangle looks like. The next one is going to be an obtuse angle triangle, and here's obviously a picture of it. And then the last one is a right angle triangle. But let's go into them in detail, just so you know exactly what to look for when trying to identify your triangles. First one, acute angle triangle. So now I'm going to use a little bit of color just to kind of help us here. And what I want you to notice is that in an acute angle triangle, can you see that all the angles on the inside are acute? This means that all the angles are less than 90 degrees. So in an acute angle triangle, you can have three different angles. As long as all three are acute, you've got an acute angle triangle. Probably the easiest one to remember. The obtuse angle triangle one isn't so difficult. Okay, it pretty much tells you exactly what to look for. And an obtuse angle triangle, you'd obviously look for an obtuse angle. Can you see this big fat angle? Okay, now that angle is an obtuse angle. And the minute you see an obtuse angle in a triangle, that is your immediate sense of, wait, it's an obtuse angle triangle. You don't even have to work out the other two sides or the two angles. You know what kind of triangle it is. Okay, so you've got your acute angle triangle, which has three little acute angles in it. Your obtuse angle triangle only has one obtuse angle. And just give us a bit of thought. Think about why an obtuse angle triangle only has one obtuse angle. Now think about it. Try and remember how many or how much, if I had to add up all three angles, what would it add up to? 180. Now imagine if I had two obtuse angles. And two obtuse angles would be way more than 180, because we know that an obtuse angle has to be between 90 degrees and 180. So there's no ways that we are ever going to get two obtuse angles in a triangle. And I ask you, I want you to go try and draw a triangle with two obtuse, because it's not going to work. Okay, go and try it. All right, moving on. And our last one is a right angle triangle, and also a very nice one to work out. We know this by looking at the right angle that's inside it. Okay, so as soon as you see a right angle in your triangle, which is represented by this little square, then you know that you have got a right angle triangle. So just to go through them again, just so you know what we're looking at, we've got an acute angle triangle, three acute angles in it. We've got an obtuse angle triangle, which has an obtuse angle in it. We've got a right angle triangle, which has a right angle in it. Can you see how easy these are? If you know your angles, you will definitely know how to classify your triangles by the size of the angle. Okay, let's go on to the one that sort of confuses people. It shouldn't really, but it does, unfortunately. Okay, so let's look at this one. Now we're going to classify triangles using the lengths of the sides. So we've got three types again. We've got something called a scalene triangle, we've got an isosceles triangle, and we've got an equilateral triangle. Okay, so these ones are based on how big the sides are. Okay, and there's a couple of factors you do need to remember. This one is a scalene triangle. Okay, and the beauty of this triangle is that all sides are different. So if you see a triangle that looks a little bit different, okay, and when I mean different, where all sides are completely different lengths, you know you are dealing with a scalene triangle. Okay, all right, next one is an isosceles triangle. And an isosceles triangle is a special triangle. Okay, it has two sides that are the same. Okay, so that means that no matter what happens, you're going to have two sides the same. But that also means that their base angles are equal as well. So I just want to show you the angle opposite your side is going to be equal to the opposite one as well. So for example, here you've got this side. That means this one is its base angle. Okay, so that's going to be the base angle of that side here. Then look at it. Think about it. If this side is equal to that side, and that side's angle is over here, do you agree that the other base angle of this side here is also going to be equal? So can you see what we've just said here? That two of the sides of the triangle are the same length, and their base angles are also equal. So when we redraw this, it looks like this. It looks like a really mean looking triangle, to be honest. Okay, but that's all we're trying to remember. So if you ever get an isosceles triangle, please remember that the angle that's opposite the side is going to be equal. Okay, so that both base angles are both going to be equal. All right. Next one is something called an equilateral triangle. Now, equilateral has the word equi in it. Okay, and I'm just going to go over it again there. So you've got an equilateral triangle. Okay, equi means equal. So I'm just going to write that here. Equi means equal. Okay, lateral is sides. So this is an equal-sided triangle, which means that you have got three sides that are all the same. That also means, and remember what I just spoke about now, remember I said that the opposite side or the opposite angle of your side is now going to be equal. So if this side is equal to that side, then that means this angle that's opposite is also, and that side's equal to that, so that side's also going to be equal, and we're going to get something that looks like that. So in an equilateral triangle, all sides are the same, and all angles are the same as well, remembering they all add up to 180. Okay, so your diagram for an equilateral triangle would look something like this. Okay, all right. Then if you go back, just quickly, for an equilateral triangle, what I want you to just quickly notice is if I take a triangle, and I know that the inside angles of a triangle add up to 180, can you see that all the angles are the same in an equilateral triangle? So in every single equilateral triangle that you have, or you've ever seen, or you ever will see, those angles will always add up to 60 degrees. Because remember, 60 plus 60 is 120. 120 plus 60 is 180. And that is your inside angles of a triangle. A way to write it would be 180 degrees divided by 3. And that is equal to 60 degrees. And that is it on how to classify triangles using the lengths of the sides and their angles. So just to recap, what we did today was all about triangles and geometry. We spoke about the angles inside a triangle add up to 180. We went through how to find the missing angle in a triangle if you're given two angles, and we also went through how to classify triangles by their sides and their angles. Please stay tuned for more. I'll be doing circles and quadrilaterals soon as well. And also, if you can just comment down below, just tell me what else you want me to do. I'm happy to do any topic in maths. As long as I'm helping you guys, I'm happy to do it. Stay tuned for more. Thanks guys. Bye.